a very physical matter for the geologist. The rock under our feet isn't a random assortment of sediments. The sediments were all lithified under specific landscapes, and there they still are after millions of years with their petrified shapes of ancient ripple marks. Although long gone, the old worlds have never really stopped existing. They form our physical reality, the land that supports us, that forms the crust of the earth, is the ever-existing presence of history. The rocks, like all history, undergo changes with time, even after its initial world has ceased being a living one. The rocks oxidize and fracture and deform and can change chemical structures. But as long as we can distinguish the timeline of events, these changes and deformations caused by later times can tell us more about the world during its initial time. We can never know for sure what the past may have really been like, but we can take advantage of the fact we live in a slice of time in many ways no different from the rest. Careful, slow, and consistent observation of the present reveals to us the most about the past. Researchers in the field of geology have used these analogs to read the rock units exposed in the Front Range area to make sense of Colorado's ancient history. This is an overview of a very special slice of time, the Cretaceous period, the final chapter of the Mesozoic world. The Cretaceous begins with the Dakota Group. The Dakota Group is composed of the Lytle and South Platte formations. These formations are part of the Dakota Ridge, which houses a rich microecosystem today, because the rocks have a damp enough surface for ponderosa pines, junipers, and mountain mahogany. In turn, these trees provide coverage for rattlesnakes and lizards. The shape of the ridge provides warm air currents which attract red-tailed hawks, vultures, and golden eagles. The lower part of the Dakota is the Lytle Formation, which consists of sandstone interspersed with shale colored tan yellow and a pinkish red. Considering the color, it's possible the sediments were cemented by iron, which was later oxidized. The sandstone is well sorted, medium-grained and cross-bedded, with occasional channels of conglomerate. Water runs through here and piles sediments from the Lytle into damp sand at its base. The fully unconsolidated sand gives us an idea of what these sediments looked like before lithification. These were deposited in river channels, which would have been active throughout Colorado 145 million years ago. Colorado at the time was likely a humid, low-lying coastal plain with lush plants and an abundance of dinosaurs, much like the famous Morrison Formation. But fossils are less likely to be preserved in river channels than in Morrison's lagoons. These two rock formations look extremely different, but really the primary difference is drainage, which changes how sediments are deposited. The severe orogeny uplifted western Utah and tilted Colorado enough to drain out the lagoons and bring in broad river channels. For fossils, this means there are only fragments of bone and small pieces of petrified wood. There's not enough to fully describe the flora and fauna, but it's not unreasonable to assume they were similar to what lived during the Morrison. However, there might have been one major difference. The start of the Cretaceous is when flowering plants came into existence. So it's possible, and one can imagine, for the first time, Colorado covered in vibrant, maybe even fragrant flowers. The upper part of the Dakota Group is the South Platte Formation, mostly sandstone again, interspersed with shales, this time colored tan and gray. The sandstone is well sorted and medium to fine grained. This formation contains uranium and oil. There are even exposed areas where the oil seeps out of the rocks. These parts of the formation are stained yellow and maroon. Unlike the lichens, the South Platte Formation has the right depositional conditions to preserve trace fossils. On the faces of exposed beddings are an incredible amount of these ancient marks. There are footprints made by adult and adolescent iguanodons. Crocodile scratch marks, beach burrows, and ripple marks are especially prominent. What this tells us is there are many different depositional environments occurring at the same time. As Utah continued to uplift, an ocean encroached on Colorado's eastern border from Kansas. The increased sediment supply and depth of the rivers from Utah, mixed with the presence of a sea, means the South Platte River Formation preserves an ancient delta. Deltas are complex systems between their distributary river channels and tidal flats, marshes, lakes, swamps, lagoons, bays, and still others. Based on the claw marks and footprints, the tidal flats attracted crocodiles and iguanodons. The iguanodon was a 30-foot-long herbivore. It had long front arms and could convert between walking on its hind legs and walking on all four. They had a beak and flat teeth. They thrived in humid and flat environments like the Colorado Delta. The Benton Formation was first deposited 100 million years ago. The rock consists of small, abundant flagstones of shale, all stained with intricate patterns. There are layers of bentonite clay streaks and medium-grain limestone. These limestones have fish bones and shark tooth fossils. The gray shale has fish scale and ammonite fossils. These fossiliferous marine rocks were deposited when the Western Interior Seaway first submerged Colorado. At the beginning of the Benton, the ocean was only tens of feet deep. At the end, the ocean was hundreds of feet deep, which is still shallow for an ocean. This shallow ocean was muddy, the sediments of which made the shale and preserved the fossils. The ocean separated North America into two distinct landmasses. The bentonite clay in this formation was made by significant volcanic eruptions that deposited thick, fluffy layers of ash on the sea floor. This compressed into thin clay layers. An oil well to the east identified an especially thick clay layer, estimated to have originally been 40 inches of volcanic ash. The ash was spread over several states. This was a catastrophic event, yet above this clay layer, life in the Benton continued as usual. Today, the remnants of these volcanic events are bentonite clay, a swelling clay that shifts foundations in the local area. The most common shark fossils in this formation are the hybodont sharks, a now extinct species which is similar to modern sharks. They were relatively small, from 1 to 5 feet long. They ate cephalopods and were preyed on by larger marine animals, like the Mosasaurus. The Niobrara Formation was deposited 80 million years ago. The rock consists of dark gray shale, with some chalky limestone made from the shallow ocean mud. Clams up to 8 inches are preserved in this limestone. The shales are calcareous. The Niobrara is poorly exposed in the Front Range region. Most is underground, with an approximately 350 feet thickness. The Western Interior Seaway was at its full extent during the Niobrara, which means the ocean never stopped being muddy. The fossils in this formation consist of cephalopods, bivalves, sharks, and gars, as well as giant seabirds, like the Hesperornis, a 6-foot-long diving bird. It has small wings and strong legs for swimming. It used its long, sharp beak to capture and eat fish and ammonites. The Pierre Formation consists of shale, flaky in some areas and thickly bedded in others. It is well sorted and very finely grained. The exposed areas tend to be in the form of flagstones on top of soil. This is the thickest sedimentary formation in Colorado at 8,000 feet. That's 8,000 feet of nothing but shale. Within these are ammonite fossils, carnivorous creatures that attack their prey with their tentacles. The Fox Hills Formation is made up of very poorly consolidated sandstone colored yellow. It's interspersed with occasional shale and some poorly consolidated root fossils. The sandstone is well sorted and medium grained, with thin bedding. The sand was deposited in sand beaches as the interior seaway transgressed. The shales were likely deposited between the sand beaches and the land in a lagoon-like space known as a barrier island complex. The Laramie Formation was deposited during and after the Fox Hills Formation, as the sea continued to regress. The rocks are composed of mostly sandstone, colored tan and pinkish red. There are shales and rare coal beds, which have been mined. Palm leaf fossils have been found in the area. The depositional environment was a coastal plain, much like the Lytle Formation. The ocean at this point in time has retreated back to Kansas, and eventually it would make its way to the Gulf of Mexico where it is today. Sandstone was deposited in a west to east river, and shale was deposited on floodplains. Coals were deposited in swamps, which likely existed due to a tropical environment. The Denver-Arapahoe Formation is the final formation of the Cretaceous period. It is composed of sandstone, poorly sorted, containing silt and pebble-sized grains, mostly conglomerate, with few well-sorted channels. It is cross-bedded, and the pebbles are rounded, but not significantly. The pebbles are made from andesitic volcanic rocks. A drastic change happened between the Laramie and Denver-Arapahoe formations. The large amounts of conglomerate means lots of nearby erosion was suddenly occurring. This was the start of the building of the Rocky Mountains. The fault block and uplift made the overlying sediments slosh off downstream. However, these pebbles are andesitic volcanic rocks from the volcanic activity due to the mountain building. The hard-to-break-down igneous rocks are the only ones preserved in the conglomerates. What ended the Cretaceous period was a mass extinction event killing off 75% of all life on Earth and causing the dinosaurs to go extinct. The world must have seemed at its end. But really, it had only broken up to start over again, to become our world. There is a lot of uncertainty about the exact nature of this catastrophe. What we've observed is an instant change in the fossil record globally. This is known as the KPG boundary. At this exact boundary is a thin layer of iridium, also found globally. Iridium is extremely rare on Earth, but fairly common in certain meteorites. This is almost certainly the case because a massive impact crater was found in Mexico, suggesting a Mount Everest-sized meteor. However, it is still only speculation if and how this meteorite caused such a great mass extinction. Some believe the death was nearly instant, over 74 hours, caused by pyroclastic flow, earthquakes, and a rise of temperature that could cause the blood to boil. But others think these claims are outlandish, because there have been other similar-sized craters found that did not cause mass extinctions. So it's a possibility there was a chain of events, or even one entirely different big event which caused the end of the Cretaceous era.